Welcome back to it. It's Maths Masterclass with Leo, and thank you for subscribing to our channel. I know I haven't been uploading, or I haven't uploaded in a while. I haven't been well. Okay, now I'm getting better. Today, I was supposed to record this video last week, but I wasn't feeling well. Today we are supposed to be doing integration using partial fraction with a repeated linear factors. On the last lesson, we did integration using partial fraction with linear factors. This case, we are doing with repeated linear factors, right? It's different. There are two different things. So, it's a very simple topic. You just have to grab some few concepts, and then once you understand the concept, then you are in. Once you understand the concept, then you are in. So in this case, we are given a simple example. They say integrate what you call 2x plus 3 all over x minus 2 squared in terms of x. We need to integrate that in terms of x. Let me just write my 2x well so that it's visible. 2x plus 3 all over x squared, or x minus 2 squared in terms of x, right? So now, what are we going to do? We are using partial fractions. For me to use partial fractions, it means I must take this fraction out of this integral. Then I'll have 2, let me just write it here. I'll have 2x plus 3 over x minus 2 squared. Right? Now, here is a very important part. Since this is linear, I'm just going to have a, right, over x minus 2 plus b over x minus 2 squared. Right? So now, good people, when you have repeated linear factors, let me say they give you, right now they give you 2, right? Let me say they give you 1 over x minus 2 to the power 3. What are you going to do when you do this? You're going to say a over the linear factor minus 2 plus b linear factor minus 2 squared plus linear factor up to 3. Right? Up to 3. So you always start at the first degree. You do up to the degree that they gave you. They gave me up to 3 degrees here. Up to 3 degrees. I'm going to start at first degree, second degree, and third degree. Remember, why am I doing that? So that when I try to remember when you do an LCM, it must take you back here. Actually, it must give you, this is your lowest common multiple, right? This is the lowest common multiple, because if I say like this goes into that, this goes into that, right? So it's similar to me, this is similar to me writing it like that, right? Writing it like that as a denominator. So now, let's continue. If I have it like that, if I have it like this, just raise here. I want to get rid of fractions. I want to remove fractions. How do I get rid of fractions? I cross multiply by my denominator. X minus 2 squared over 1. What I do on my left hand side, I must also repeat on my right hand side. Cross multiply by x minus 2 squared over 1. Right? Now, this one and this one, they will cancel. Then I'll be left with 2x plus 3 is equals to a. Right? This one goes into this one once. So it means I'm going to be left with x minus 2. Right? But this one and this one, they will cancel. I'll be left with plus b. I'll be left with plus b like that. So now, when I'm here, I need to get the value of a and b. But I know if I say let x b is equals to 2, then I'm going to get the value of a only. What about the value of b? How am I going to get the value of b? So now, what I'll do, I'll just say expand. I'll have 2x plus 3 is equals to a x minus 2a plus b. Right? This is what I'll have. Now, I'll take everything that is x. Everything that is x, it means I'll have 2 here, which is equals to a, right? Everything that is the variable x, which is this one, so I'll take it as this one, and then here it means I had x. Okay, let me just show you a simple way to do this. I'll have 2x, which is equals to, I'm taking everything that is x, ax, right? Means the x's, they'll cancel each other. See, then I'll have the value of a is 2. Similar to me saying x, where there's x I had 2, which is equals to a. Similar, you see. Then now, let's take everything that is a constant represented by c. It does not have the variable x. So now, everything that is a constant, what do I have? I have 3, which is equals to negative 2a plus b. Right? Everything that does not have the value of x. So now, I have 3 is equals to negative 2, but I already have the value of a, which is 2 plus b. Right? Then solve for b. This will give me 3 is equals to negative 4 plus b. Therefore, b is equals to 7. If I take this 4 to the other side, then add them, I'm going to get 7. Now, am I done? No. I need to integrate it, not get the partial factors or those things. I need to integrate it. How do I integrate it? I'll have to go back here and substitute the value of a and the value of b. Therefore, I'll have a. Okay, let me not say a. Let me say, instead of having a, I have 2. I got the value of a as 2 over x minus 2 plus 7 over x minus 2 squared. Right? I need to integrate this in terms of x. I need to integrate that in terms of x. Right? How do I integrate that? Now. Okay, now what I'll do, I'll just say, since I have this, separate them. Separate this, I'm going to have the integral of 2 over x minus 2 dx plus the integral of 7 over x minus 2 squared dx. Right? Remember what we did before this chapter, 2 lessons before this one? We did the u substitution. We need to use the u substitution here for us to can get the answer. So what I'll do, this one is easy, I can integrate it. The integral of this, I'll have 2 ln, okay, we'll just write it at the end. Let's just say 2 over x minus 2 dx plus this one, I'll have let, why did I write that before? I wrote let me just say let, okay, wait. For me not to confuse you, let me just write this one. 2 ln of x minus 2, right? That is the solution when you integrate this. Plus, this one, I did not integrate it. Let me just say 7 over x minus 2 squared dx. Right? So, now, I need to integrate this. I'll introduce what you call let u be x minus 2. Right? But I'm not going to substitute it here. Why? Because I already integrated this. I'll substitute it here. So now, if I have this, it means I'm going to have du over dx is equals to 1. Because here, the factor is 1. Right? There is 1. So now, dx, it means it will be du over 1. Which is similar to saying du. Right? Then now, when I have this, I need to substitute it there. I'll have dx substituted there, and then u substituted there. I'll have 2 ln of x minus 2 plus the integral of 7 over u squared du. Right? Over u squared du. Because this is du over 1, which is similar to me saying du. Now, I'll have 2 ln of x minus 2 plus this. I'll just rewrite it and have 7 u to the power minus 2 du. Right? Then 2 ln of x minus 2 plus, when I integrate this, I'll have 7 u to the power minus 2 plus 1 over minus 2 plus 1, right? Plus c. Am I done? No. I can just simplify that. I'll have 2 lim of x minus 2 plus, okay, this is, okay, let me just write it and say this is, will give me 7u to the power minus 1 over negative 1, right? Plus c. Let me just try to rewrite it there. Sorry, taking a lot of space. Let me just try to write it there. I'll have, this will give me 2 ln of x minus 2 plus, not plus, minus, plus and minus, minus 7 over u plus c. But I know that u, this, I know it. So I'll have 2 ln of x minus 2 minus 7 over x minus 2 plus c. Just try to underline this one so that things are not there. There's my solution. When I integrate, which one was I integrating? Okay, when I integrate 2x plus 3 over x minus 2 squared, the integral of this is the solution, right? That is the solution. I hope you understand, and I hope you enjoyed the video. Make sure you subscribe and share the content with your friends. Tango!